Welcome back to my channel. Today we will be treating on implicit differentiation. Implicit differentiation as a concept, it has to do with finding a given derivative of a particular function, and to obtain that derivative of that function there are some guidelines, some rules to adhere before finding that particular function, that is the derivative of that function. To find the derivative of a given function, the y ds we differentiate the given implicit function term by its term with respect to s, noting that whenever we differentiate any variable y with respect to s, we attach the y ds to the result of what the term gives. For example, having x squared plus y squared equals to 0, find the y ds of this function. Now, to find the dy dx of this function, having known that whenever we differentiate a variable y, we attach the y dx. Now, the derivative of x squared, is 2s plus the derivative of y squared, 2y, dy dx equals to 0. Now, taking 2s to the other side of the inequality sign will be 2y dy dx equals to minus 2s, because any variable crossing an inequality sign, the sign changes to negative. If it is positive, it changes to negative, and if it is negative, it changes to positive, vice versa. Now, dividing both sides by the coefficient of the y ds, we'll be having the y ds to be equals to minus 2s all over 2y, which is equals to minus s all over y. Now let's look at other example. Given x squared plus y squared minus zy equals to 9. This function, it has z companion y, and whenever we are solving any related function like this, solving for z companion y, we are to solve it separately. How do we solve this particular function separately? You solve separately by keeping z constant and differentiating y, and keeping y constant and differentiating for z. Now, let's find the y ds of this function. Solution. Finding the derivative of x squared. The derivative of x squared is 2s plus the derivative of y squared. Always remember that whenever you are differentiating a variable y, you attach your y ds. Now, differentiating y squared will be 2y dy ds minus differentiating z companion y, will be having, keeping z constant, we differentiate y, then we attach our dy ds, plus keeping y constant, we differentiate z. Differentiating z, will be having 1, so we equate it to 0, because the derivative of any constant is 0. At this point, 2s plus 2y dy ds minus z into 1 will give us z into the y ds, plus y into 1 will give us y, equals to 0. Opening this bracket with this negative sign, we will be having 2s plus 2y dy ds minus z dy ds minus y equals to 0. Now, by rearranging, that is, by collecting like terms, we'll be having 2y dy ds minus z dy ds equals to 2s. Whenever a variable crossing the inequality sign, the sign changes. Now 2s crossing the inequality sign will change to minus 2s, and when minus y crosses the inequality sign, it changes to plus y. Now by factorizing, that is by bringing together the common terms, we'll be having dy ds into 2y minus z equals to minus 2s plus y. To obtain our dy ds, we have to divide both sides by the coefficient of dy ds, and by doing that, we'll be having our dy ds to be equals to minus 2s plus y all over 2y minus z. Here is now our dy ds. From this function, s square plus y square minus z companion y equals to 9. Our dy ds is equals to minus 2s plus y all over 2y minus z. Now, for the sake of practice purpose, let's do other related example. Now, having y cube plus z cube minus s cube equals to 0. Find the y ds of this function. Y cube plus z cube minus s cube equals to 0. Finding the derivative of this function, whenever we differentiate a variable y, we attach the y ds. Now, the derivative of y cube is 3y square plus the derivative of z cube is 3z square minus the derivative of, finding the derivative of y cube, we are having 3y square dy ds plus the derivative of z cube 3z square minus the derivative of s cube 3s square equals to 0. By making the y ds the subject of the formula, we'll be having 3y square dy ds to be equals to, taking this 3z square minus 3s square to cross the inequality sign, we'll be having minus 3z square plus 3s square. Dividing both sides by the coefficient of the y ds, our dy ds will be equals to minus 3z square plus 3s square all over 3y square. Therefore, the function y cube plus z cube minus s cube equals to 0. The dy ds of this function is equals to minus 3z square plus 3s square all over 3y square. Thank you for watching this video. I hope this video has given you more insight or better insight on how to do justice to implicit differentiation. Don't forget to always like, comment, and click on the subscribe button for more exciting videos. Thanks.